Hello again, physics. Here's how we do a ratio problem. So this is from homework 6. This is problem number 4. And the question we have is, how do the kinetic energies of a truck and a car compare if the truck has 21.6 times the mass, but the car has 2.25 times the velocity? So these ratio problems, these are tricky if you've never seen them before. Once you get the hang of them, they're actually not so bad. So what are we actually looking for? How do the kinetic energies of the truck and the car compare? So let's start with step What are we actually looking for? We're looking for how these things compare. So what we really want is kinetic energy of the truck over kinetic energy of the car. So that's how they compare. When you see the word compare, that should mean let's do a ratio of these things. So kinetic energy of the truck divided by kinetic energy of the car is equal to question mark. And what will the units be? There actually are no units, which can be a little bit confusing. So we're talking about kinetic energy. So you might think the units is just going to be joules because it's energy, and so it should be joules. But when you're taking the ratio of one kinetic energy to another, the ratio you get doesn't have units. Essentially, it's going to be joules divided by joules, which is going to give us no units. So, yeah, there are no units for what we're looking for. So here's how you do these things. First, I would recommend somewhere over to the left, make a list of the things that you know. So we know something about these masses, and we know something about these velocities. So let's see. Mass of truck, something, mass of car. All right, so we know that the truck has 21.6 times the mass of the car. So that means the number is 21.6. Does this one go on the left or on the right of what I've just written? The mass of the truck is 21.6 times the mass of the car. So that one's going to go there. Convince yourself that that makes sense. So whatever the car weighs, whatever the mass of the car is, the mass of the truck is 21.6 times as big. And now we have to figure out their velocities. So velocity of the truck, something, velocity of the car. So this number is 2.25 times. So is that going to go on the left or the right? Well, the car has 2.25 times the velocity of the truck. So that means that's going to go over here on the left. 2.25 times. So, yeah, the velocity of the car is 2.25 times the velocity of the truck. So convince yourself that that also makes sense. Sorry, just making sure that we're still recording. So where do we go from here? A good idea would be to write the formula you're going to use, just to remind yourself, that kinetic energy is equal to 1/2 mv squared. We're going to be using that idea. So the next thing we're going to do is we're going to make a ratio. So I'm going to write kinetic energy of truck divided by kinetic energy of car. So that's what I have. This is going to equal something. This is going to equal something over something. So what you want to do is make the top half equal to what the top half is equal to, and then make the bottom half equal to what the bottom half is equal to. So that means kinetic energy of the truck is going to be 1/2 mass of the truck times velocity of the truck squared. So the top half of this is equal to the top half, and the bottom half should be equal to the bottom half. Kinetic energy of the car, 1/2 mass of the car, velocity of the car squared. So I've got this. Right away I can start canceling things out. 1/2 divided by 1/2, that's just going to go away. That's just going to equal 1. Now at this point I can't cancel anything else out. I can't cancel the m's because mass of truck does not equal mass of car. And I can't cancel the velocities because velocity of truck squared doesn't equal velocity of car squared. So getting rid of the halves is all I can do for now. So now we keep going with this. And then we have to start deciding to sub things in or keep things. So we're going to go term by term and decide whether or not we want to keep it or sub for it. So the first thing we have on the top is mass of truck. Do I want to keep that or do I want to sub for it? The way you decide is if it's really easy to sub for it, go ahead and sub for it. If it seems like it would be a little bit difficult, don't sub for it. So if I'm looking at this, mass of truck is equal to 21.6 mass of car. That would be really easy to sub for. I can just replace m sub t with 21.6 mass of car. So that one, very easy to sub for, so go ahead and sub for it. The next term we have is on the top, v sub t squared. So when I look at this guy, would that be easy to sub for? Well, I can't just go right ahead and plug it in. I would have to divide the 2.25 over to the other side. That seems like it would be a pain. So I'm not going to sub for v sub t. I'm just going to keep that one. So that's going to be v sub t squared. Now on to the bottom. A couple ways of looking at this. Let's keep with the sub for it if it's easy. Keep it if it's difficult. So mass of car. So we're back over here again. Would it be easy to sub for the mass of the car? It wouldn't. I'd have to divide that 21.6 over. That would be annoying. So I'm not going to sub for the mass of the car, so I'm just going to keep the mass of the car. And finally, v sub c squared. Is v sub c going to be easy to sub for? Yeah, it is, because I have v sub c is equal to something. So that would be easy to sub for. So I'm going to sub for it, and I'm going to be careful because of the rules of algebra. It's going to be in parentheses 2.25 v sub t, and that whole bit gets squared. Don't forget to put the whole thing in parentheses. The rules of PEMDAS, the rules of algebra, you're going to have to square the whole thing. So now we can start canceling things out. So m sub c divided by m sub c, that's just going to go away, and the 21.6 stays. Now I can't cancel the v sub t squared because of that parentheses in the bottom. I've got to keep going with that a little bit. So I'm kind of running out of room. Let me just rewrite what I've got here. K sub e, I'm sorry, ke sub t over ke sub c. And right now what we have is that is equal to 21.6 v sub t squared, and on the bottom 2.25 v sub t, and that whole quantity gets squared. And again, I can't just cancel out the v sub t's, and I can't cancel out the squared. Algebra doesn't let you do that either. What you actually have to do is go ahead and just square the thing on the bottom. If you square, well, let me write the top first. So the top, that's going to stay the same, 21.6 v sub t squared. If you square 2.25 v sub t, what you're going to get is 5.0625 v sub t squared. And now I can cancel out more. So now I can go v sub t squared divided by v sub t squared. That is going to go away. So what does this leave me? This leaves me with 21.6 on the top, 5.0625 on the bottom. Now, of course, I can simplify that. Just ask your calculator, 21.6 divided by 5.0625, and what you're going to find out is kinetic energy of the truck over kinetic energy of the car is equal to 4.27. So you can put a box around it. You can be done just like that. That's one way of writing your final answer. Another way of doing this is that might make a little bit more sense, or at least the idea just kind of reads a little bit easier. If we multiply both sides of this by ke sub c, that's going to give me ke sub t is equal to 4.27 KE sub C. So this is another acceptable way to write your answer. And I kind of like this way because what this idea is telling you is that the kinetic energy of the truck is 4.27 times the kinetic energy of the car. It's the exact same idea as the first thing. It just logically it makes a little more sense. The concept's a little easier to see if you write it that way. So hopefully that helps.